I guess this is supposed to be over outdoor wiring and GFIs, installing GFIs, and proper management of GFIs. It kind of started back in the late 60s, early 70s, whenever they started introducing these ground fault circuit interrupters. They're mainly a personnel protection piece of equipment that protect people from being electrocuted. It should only take, it does not take very much electricity to hurt a person. I mean, these things are designed to trip at 5 milliamps, is what they're designed to trip at. They measure the difference of amperage between the power going out and the power coming back. They monitor how many amps that is, and then whenever there's a difference of that milliamp, then it'll kick off within like a 40th of a second. So, I mean, it happens really quick. Of course, I mean, they've obviously upgraded them since then, even though they're probably the same size as they were back in 1970. But back in the late 60s, they introduced them for pools and such. People were getting electrocuted inside of pools, and then now everything on the outside of your house has to be GFI protected. Everything in the garage has to be GFI protected, and everything within 6 feet of a water source has to be GFI protected. That way, you know, you're not washing your hands and then you plug something into the wall outlet. Designed to trip off if you get electrocuted. So, these are just a few little visuals that we have here. Over there is kind of an outdoor type setup that you would see on the outside of the house. It's a waterproof box. That is a in-use GFI cover. You have to have that on the outside of your house. Like if you plug in Christmas lights or something, you're going to leave them plugged in for a long period of time. You're supposed to have an in-use cover that prevents any moisture from leaking inside and getting into the GFI. There's a gasket that goes in between that cover and the box.
A little hole right here for the cord to go through. You should have to chop the cord off. That's how that works.
Yeah, that way the lid closes all the way, and if it rains or snows, moisture's not going to get up inside of there and get into your outlet.
Well, which is a good idea too, because I mean, you get moisture and it's going to trip.
Yeah, it's going to nuisance strip on you on its own. I know just because the outlet does not look like this does not mean that it's not GFI protected. Like, I know in some house wiring, they'll put a GFI outside and then run wires into the bathroom and just have your normal outlet inside your bathroom, and you know, you'll be blow drying your hair or something and it'll trip, and then you don't know where it came from. Well, or you don't know why that tripped, or it's off. You go to your breaker panel and all the breakers are on. You might go outside and look around at your outlets outside of your house because one of these might be tripped. You can go around. You're supposed to test these once a month anyway. Go around and hit the test button, make sure they click, and then you hit the reset button, make sure they reset.
This one's actually live right now. This one's kind of handy. It's got a little light that shows you that it's got power coming to it.
Yeah.
You hit the test button, you hear a little click. Light went out. Once again, handy. Push the reset button, you can hear it click back on. If it doesn't click back on, either you got a problem here or something's plugged in down the line that's actually causing it to trip. Like maybe you got an extension cord plugged in outside and the head of it's sitting in some water or something. That's the biggest culprit with these is moisture.
I think these things only have, what they do, whenever you hit the test button, it puts a short between the two legs in there and it trips it. And then you reset it. Well, these things are only good for so many trips. So I don't know if that's a way to get them to buy more outlets for them, I guess. So this little setup here is what I was going off of earlier, that these are sometimes GFI protected too. This is more of the installation part. I don't know.
We can show you. So if you look at the back of these guys here, there's two different kinds of that says line and load on here. Your line is power coming in, like say from your panel board, and there's stuff called load, which is the power going out from the outlet. So what he's showing you there, the line side would be the GFI, and the load side would be just the regular outlet over there. And basically what that means is the line coming in is the power going to that outlet, and it's protecting that. Then everything past that GFI is going to be protected by the GFI if you wire it to the load side, which is like he was talking about when you have an outlet that looks regular but it's GFI protected.
And technically, whenever you buy a GFI outlet and it comes in a box, it looks like this. There's it comes with a cover in there. It comes with instructions, and it also comes with these little stickers. And if that is a GFI protected outlet, even though it looks normal, you're supposed to put. There's a sticker that says GFI protected outlet.
That way you know that you have a GFI protected outlet, basically. So what you got is, as you look at these guys right here, you got power coming in. You're gonna have your hot. You're gonna have your neutral, which if it's been wired recently, hopefully it'll be black and white. Black will be your hot wire, neutral will be your white wire. You got your this little tape right here is usually only used, that's over the load side, because if you go into this side with your power, it's not going to work. You want to come into the line side with your power. That's the biggest way to just make it not work. It would be frustrating. Yeah, so to wire on another outlet, you come in to the line side, then come back out with the load side, then on your next outlet.
Mainly they do that to save money. It's because the GFI outlets are 20 bucks a piece, and the other ones are $2 a piece. So
one thing I'd like to point out is this is a 20 amp outlet here, so it's built a little bit tougher than your standard 15 amp outlets that you'll find at your house. You notice the back of this has got the terminals that you can go into the back of, but you actually screw down the screw to kind of clamp onto it. Some of your cheaper outlets will have I guess you'd call it a compression connector or something, where you just shove the wire into the back of it. Don't do that. Go ahead and twist your wire around the screw itself. Shove it into the back. I've been in several houses where they all of a sudden just lose power to the rooms and stuff. And it's because over time, you're plugging in, pulling out, just the manufacturing. And over time, that connection will weaken and it'll be loose, and you'll get a bad connection, or it'll burn up the outlet and things like that. So this is a much tighter connection. Better.